Hey guys, so in this video I want to talk about the work energy theorem, which is basically an equation that's going to connect work with kinetic energy, and it's going to allow us to solve problems in a different way. Let's check it out. Alright, so the work energy theorem is this equation right here, and it says that the net work, or the work net, the total work, equals the change in kinetic energy. Now, change in kinetic energy obviously means K final minus K initial. Okay? And work net means the sum of all works. All right? So remember, we can calculate work done by a force using this equation. And remember that the net work can be calculated using either the sum of each individual work or the work done by the net force. You can find the net force by combining all the forces and then find the work done by the net force. And remember also that kinetic energy is half mv squared. So those are all the equations that we need to talk about the work energy theorem. So it says here, it gives us a way to find the initial or final velocity of an object that is acted upon by forces. So if there's work done, there will be a change in kinetic energy, and obviously kinetic energy has a velocity in it. So you should see a v inside of these guys, and these are the kinds of problems we're going to have. We're going to be pushing on a box, and the box moves, and we want to find some velocities. Okay. So I'm going to do the first example here, and then I want you guys to try the practice problem. Example 1, a 2 kilogram object has a kinetic energy of 4 at point A and a speed of 3 at point B. So I'm giving you 2 points. I don't really give a sense of whether one is to the left or to the right. It doesn't really matter. But let's start writing this stuff down here. Mass is 2. I'm going to say the kinetic energy at point A, Ka, is 4. And the speed at point B is 3. Okay, let's just get the information down. And then it says find the speed at A. So find VA. Notice that I know Ka, and then I'm looking for VA. Well, all you have to do is find an equation that relates those two variables, and it's pretty easy. The kinetic energy equation ties the two together. So not only can I find K if I have V, but I can also find V if I have K, and that's the idea here. So I'm going to write that Ka is half mVA squared. K is given, it's a 4. The mass is a 2. So this 2 cancels with this half here. And then I have that VA is going to be the square root of 4. Therefore, VA is 2 meters per second. Okay, that's it. For part B, I want to know the kinetic energy at point B. So what is KB? Very similar, just backwards. I gave you VB, and I want to know the kinetic energy at point B. This is even more straightforward. KB is half mv squared at point B as well, and we just have to plug in the numbers here. The mass is 2, these two cancel, and the velocity is 3 squared, so KB is 9 joules. Okay, that's VA, that's KB, 9 joules right there. Part C says find the net work from A to B. Find the net work from A to B. So what is the net work from A to B? So net work I can calculate by doing the sum of all works, or by finding the work done by the net force. And now there's a third way you can do this, and that's the big idea of the work energy theorem, is that it gives you a third way to find work net, which is by finding the change in kinetic energy. Okay, I'm not able, through this problem here, I'm not able to find the net work because I don't know all the forces that are acting on this. And I don't know the net force, so I'm going to have, but I do know velocities and kinetic energies and stuff, so I can do it this way. So if I'm going from A to B, then the net work between A to B is just the change in kinetic energy, so it's kinetic final, or kinetic B, minus kinetic initial, kinetic A. And I know these numbers. Kinetic B we just found, it's 9, and kinetic A was given, it's a 4, so the net work is 5 joules. Okay, that's it. So all we've done is play around with the kinetic energy equation and with the work net equation, and the answer is in there somewhere, right? So cool. I want you guys to try out practice number 2. Let's give that a shot.